Hello everyone, welcome to Practical Computer Networks Discussion 2. I'm Kumar Saurav again, and I'm having a bad day, so sorry if I make any mistakes. First, I get disturbed 4 times while making this video, and 5th time I made this video, and I realized I forgot to start the recording. Yes, I don't know what's happening to me. Anyway, I'm a little dizzy. It's around 4 a.m. in the morning here. Still, let's start. In the previous video, what we saw in previous video, we discussed about what we are going to do in this series. Who am I, and what are my aims, and a little concepts of networks. Well, it will worth watching that video if you feel like it. Anyway, so networks, computer networks, coolest thing ever. Yes, other than Counter-Strike and Dota and some other things. Computer networks is very cool. I'm telling you, really. So let's start. Whenever someone says computer, I'm repeating this line for 5th time. Whenever someone says computer networks, basically this is what I picture. This is what I picturize. This is what comes to my mind. What is this? Okay, here I'm sitting in my room in front of my machine. I'm connected to internet, and I'm connected to internet, and many other guys are connected to internet from all over the world. Suppose this guy is from New Delhi, this guy is from New Jersey, this guy is from not from a new city, this guy is from Virginia, and this guy is from Shanghai, right? And this server is located in Richmond. That's in Virginia, right? Because that's the place from where the Lamb of God is. It's Richmond. Okay, so I'm connected to internet. What is internet? What is internet? It's a network of networks. It's a gigantic network. It's made up of different huge and small, a lot of networks. That is what internet is. If you this sometimes we call it cloud, right? Suppose somehow you get to look inside that cloud. You know what you will see? All you will see is different networks connected together in many fashion. This is a network, this is also a network, this is also a network. You can't imagine in how many ways they are connected. For reliability, of course, there is also another network, right? These all are connected together, and finally we are connected to it. Okay, so this is an internet. This is internet. Every network is connected together to form a really big network. That is internet and cloud, and WANs are inside it. Some parts are called WAN, etc, etc. That's internet. Anyway, so first building block of internet is local area network, then comes wide area network, etc, etc. So first local area network, that's most basic thing. That is where we reside. Are you in a LAN? Are you connected to a local area network? One more thing, I'm going to discuss about wired networks, not wireless networks. Wireless networks have different theories and set topologies, etc, etc. I'm going to discuss about wired networks. In wired networks and in LAN, in local area network, what do you use for connectivity? What do you use to connect different computers? Okay, if you are in LAN, check your computer. There will be a thick wire connected to your computer, your PC, your machine, by a transparent jack will be there with two lights or four lights, a blue, a green, and a red, I guess. So this is Ethernet wire, right? And these are those connectors, RJ45 connectors, I recall. Yes, RJ45 connectors. These connectors have uh, many wires, different colored wires for for different for leave that. These are RJ45 connectors. This one connector is connected to your uh, Ethernet port. Ethernet port is the port where we connect the Ethernet wire, Ethernet cable, right? And Ethernet port is a part of network interface card. Network interface card is responsible for dealing with networks and for network activities. This is how a network interface card looks like. Sometimes we call it NIC. NIC, right? This is already installed in your PC. You can see this is Ethernet port, and these are those lights I was talking about. This is already installed. This is inside your PC. You can't see it until you open your PC, right? You can have one or more NIC. Anyway, and you are connected to internet. Suppose this is a Google server. I'm in Google. Horrible penmanship. Anyway, I'm in India, Odisha, India, right? I want to access a page of Google. I want to do a Google query, Google search. So I send a request to Google. There are routers and switches in between. There are main networks. Suppose this is a network. Fine. Suppose my queries, my whatever data transaction I'm doing with this Google server, this particular Google server. Suppose my packets are taking this path, back and forth. My packets are taking this path. Suppose for some reason this path has damaged by technical problems might be there, or say it's sandy or it's tsunami. For that this line got broke, right? What will happen? Because I'm using Google, so definitely my packets will choose another path and it will continue serving me. And since I'm not I'm not doing some serious work, some serious transactions with in any financial database or something, so I don't need to worry. What if I'm doing some transaction with a bank's database? There might be a case when data transaction is broke due to these things, these networks, and some of my transactions are lost in the way. Some of the Suppose I'm updating my account, and those updates are lost because the connection broke. For some reason, let's just say it, for some reason my updates are not able to reach to this server, then definitely I'll be doomed, right? So internet is reliable, but less reliable than a dedicated line. What is a dedicated line? Let's say I'm rich enough to afford a lot of money, then I'll hire a dedicated line directly to my database server at my office in New Jersey or New Indiana, in Virginia suppose. So what I will do, I will hire some company. I will contact some companies who provides dedicated lines, and I'll ask them that, hey, I need a dedicated line to my server at Virginia. So they will provide me with their with their dedicated line, whatever. So what happens in dedicated line? This is their own personal network. Suppose AT&T. Suppose AT&T. In it, AT&T also provides a dedicated line. Like suppose I'm using AT&T's dedicated line. They have their own networks, right? So they have people monitoring their lines, their servers very frequently. So I get a private line to my server, and so I get much more reliable connection to my server. But for that I need a large amount of money to buy a dedicated line. But I will get more reliability and I will get more security. These lines are much more secure than internet. Since we are talking about hacking, these are things we must take into consideration. So once your packet gets out of your LAN, it goes to WAN and different networks. For long distance transaction, they use fiber optics. They're fast. Trust me, they're class. Fiber optics is class. Anyway, so this is a whole idea of whole overall how internet. What is the internet? A very basic idea. I'm sure you must be knowing this. What is this? This is a small network. Suppose this is my system. This is me. This is my friend. This is my neighbor. This is also my neighbor. We are in a LAN. We are using Ethernet wire. We are using Ethernet wire doesn't mean we are in a LAN. Ethernet wire is a part of it. Fine. So don't get confused. I will explain all the technical details of a LAN later videos. Don't worry. And there are a lot of career options in networking. A career here, a career there. You are in Cisco, then if you want to go to Cisco, then I think Cisco is, doesn't matter what I think, but Cisco is a mighty warrior in networks. There are also networks. There are also careers for the guys who are who do these wire things. They connect wires. They do hardware networkings, and there are also career options for software networking guys. There is a course CCN, Cisco Certified Network Associate. Then you go for Cisco Certified Network Professional, Security Professional, etc., etc. Very good things. You must just Google it, CCNA. You will get all the things cleared, and you will get a career option, a much more interesting career option than my career. Anyway, so if you use Cisco simulators and softwares and Cisco books, if you refer them, you will find these notations, these symbols all around the book. This is a symbol for switch in Cisco, and this is a symbol for router. From now on, I'll be using these symbols for switches and routers. So please remember these symbols, please. Okay. This is a cloud. This is not a cloud. This is cloud or WAN or anything. This is just larger than my LAN, right? Suppose I want to access. I want to copy some movies which which are in Basina, which are with my friend, my neighbor here. Okay, my neighbor has some movies and I want to copy them. If you use Windows, there is a network explorer. If my neighbor has shared their movies, then I'll be able to see the list of those movies by network explorer, right? Now if I want to copy that, copy those movies, of course there are also data transactions. Also I send request to my neighbor's laptop, my neighbor's system, that I need this particular movie, I need this particular data, and my neighbor's system will reply me back. But this switch, it's center of my whole network. Every packet will pass through this switch. Suppose I'm sending a packet destined for this guy here. This switch will strip out this packet. This switch will process the packet. It will see what are the informations which are inside that packet. It will see the source address, the destination address, and accordingly it will send the packet to its to whom it may concern. To whom it may concern. It's a catchphrase I read somewhere. To whom it may concern. In applications, right? Anyway, so suppose this packet is destined for this computer. My switch will check the destination address, and if the destination address is within my network, within my LAN, then it will send that packet to this guy, right? Then the transfer will start. Now what if I want to access a page of let's say www.twitter.com. Twitter, right? You know Twitter, right? Twitter. Definitely Twitter server is not in my local area network. It's not in my LAN. So my packet will go to this switch. It will contain my source address, which will be mine, and the destination address will be of Twitter server address, right? So my switch will process the packet. It will check the destination address. It will see that the destination address is not within my network. It will send the packet to its default gateway. Now what is a default gateway? For now, let's say default gateway is very next device to which a particular device will send the data, right? For me, for my computer, this switch is default gateway, because whatever transaction I want to do with network or internet, first I will ask this guy. First I will go to this guy. I will send every packet to this guy. Then after that it will direct me towards to the right path. Okay. Now suppose I have sent a packet to this switch, and destination address is not within my LAN, and this switch is connected to a router and my network. So obviously the default gateway for this switch will be of this router. Get it? Please ask whatever you feel you are having trouble with. Whatever your doubts are, please feel free to ask in comments. I'll be more than happy to answer your doubts. Okay. Now this router may be a starting router, entry router for your WAN, or maybe a router of your ISP. ISP is your internet service provider. Like in India, there is BSNL, MTNL, and I don't know about USA. Okay, AT&T maybe, whatever. So this may be the router of your ISP. Now this router is connected to many other networks, right? This network, this is switch, it has more computers or less computers, and more networks and more networks. Finally it is connected to the cloud. Fine. Now Twitter server is somewhere around here. So now my packet will go through some weird network paths, some zigzag paths. Finally, it will reach to my destination. Packet will trace back whole path and it will come to me. It will come to me. Now, for my computer, this whole thing is a cloud. Okay? Uh-oh. For my computer, this whole thing is a cloud. And for anyone sitting over here, suppose in my network there is a HTTP server, okay, which is hosting some website. Suppose this guy is trying to access, this guy or this girl trying to access this website. So packets from his or her computer will travel through whole this path. It will come to finally my network, right? So for this guy, this whole thing is cloud. Understand? This whole thing is cloud for this guy. For me, this whole thing is cloud. Get it? Now, I think you have a rough idea of what is a cloud. What is cloud? What we refer to when we say cloud. Okay. For me, if this whole thing is a cloud, this whole thing is a cloud, it's messy. For me, this whole thing is a cloud, then this is my LAN. This is my local area network. This is not the exact definition. I'm just stating it. Okay. So this is a part of LAN. The technical details of LAN, as I said, I'll express later. So you get the basic idea what a cloud about cloud and LAN and network, etc., etc. Some basic uses that some basic applications uses that require internet or network connectivity. There might arise, you might ask me a question, why have you written, okay, hello Kumar, why have you written internet/network? Why not just internet? Because if we use web browser, we have to use internet to get anything. Well, my friend, that's not fully true. Consider a scenario. This is switch, this is my LAN, and in my LAN there is a HTTP server, right? There is a HTTP server which is hosting some site and is in my LAN. So if I want to access that website, I will be using my web browser, but I don't need internet connection. I just need my network, only my network to do it, right? So I will just type in the IP address of this server and I will get what I want. But it's not a survey figure, but almost 98% of the times we use web browser to access the pages which are located elsewhere, which are located outside our LAN, which are located in the cloud, in some remote locations, right? I'm sitting in India and I'm accessing Google via my web browser, Mozilla Firefox or Google Chrome, whatever. and the Google server is in, suppose, New York, then I need internet connection to access pages of that server, right? FTP. Um, Talk about FTP servers. Well, I'll talk about that later. Database applications. Consider a situation. Uh, okay, like I use Aircel. It's a telecom service provider company. Suppose I have some problems. I have some doubts. I call the operator of Aircel. Right. I call the operator of Aircel. The call center is in, let's say, for New Delhi. Right. What's wrong? I don't know. I'm calling. It's me. It's me. I'm calling the Aircel operator. It's in New Delhi. The call center is in New Delhi. Uh, when I call, the operator checks my number, and it gets and the operator clicks on details, and whatever detail I have given when I was filling out my registration form for phone number, it will be flashed there. Okay, like my name, my address, from where I am, my date of birth, maybe my father's name, my mother's name, whatever I have given, the operator can have if he is authorized. Now I talk to the operator. My queries are solved. Then I cut the call, right? And the machine over here records those details, that okay, Kumar Saurav has called on this date and talked with this particular operator for this much time. Now all the data will get stored in a remote centralized database, and this database will store all the details which I just provided. Anyway, and there are lots of operators which are connected to that server. Okay, hundreds of thousands of operators are there. Fine. Next time I call, suppose I call next time to this operator. This operator can retrieve all the datas which are stored in this database, and then he will be able to know that when did I call, for how much time did I talk, and all those things. This database may be inside that building, may be located elsewhere. Suppose the operator is in New Delhi and the server is located in Mumbai, right? So operator will access that server, will access files of that server, the database, and the operator will have all the informations. What is basically we doing here? We are using some database applications to retrieve the data and using network. That's what I wrote, right? Now instant messengers. Oh come on, you know it. Do I need to explain? Okay, I'll name some. Yahoo, MSN. I don't think I need to explain. FB chat. I don't think I need to explain. You guys are clever enough. Email. Okay, same. Gmail, Yahoo, Hotmail, etc. etc. Online games. Have you played Counter-Strike? I played Counter-Strike online. So here I am sitting in India, connected to a server. I see a common port in Counter-Strike servers is 20715 or something like that. Anyway, so I connect to a server Suppose an international server. Someone is at uh, someone is in Beijing playing Counter Strike on same server, and someone is in Manhattan. Someone is in Manhattan playing on that server. Suppose I am targeting this guy with my AK-47 and I click my left mouse button. So what basically is happening here? The game, the Counter-Strike machine, the Counter-Strike process or whatever, I don't want to get into those things. My computer will send data to this server that okay, this is the screen. Saurav has targeted this coordinate, this particular coordinate with his bullet from this distance. The server here will process all the data, will see if this guy is at this position, then the bullet will hit him. If this guy is not at this coordinates, then bullet will not hit him. Fine. If the bullet hits him, then then what will be the reaction? What will be the result? This guy may die. The character of this guy may die. So if this guy's health is low, then definitely his character will die. For let's say Arctic Avengers, Arctic Avengers is dead. So it will fall down. It will fall down, and this information also this information is passed to me who killed that guy, to this guy who is being killed, and this guy who might be a spectator, right? So this server is located in some remote location. All the data are going to it, going and coming from it and to it. This server is processing the data and sending reports to me, to a guy in Manhattan, to a guy in Beijing, right? So that's how online games uses internet network connectivity. There are some factors which highly influences the performance of a network. There is speed, there is delay, and there is availability. I'll talk about these things later. For now, let's roll it out. For now, I'll talk about speed. What is your internet connection speed? Well, my speed is 1.5 Mbps. 1.5 Mbps. What does Mbps stands for? Some of you might say it's megabyte per second. No sir, you are wrong. It's not megabyte per second, it's megabit per second. I will tell the difference. What is a byte? A byte is a single character. Let's say I write A. It's 1 byte. I wrote ABC. This whole is 3 byte. Right? Now 1024 byte equals to 1 megabyte. 1 byte into 1024 equals to megabyte. Once again, 1024 megabyte equals to 1 gigabyte. 1024 gigabyte goes to 1 terabyte, and list goes on. This is the hierarchy you need to follow. 1024, 1024. But this bit thing is exception. What is the relation between bit and byte? Anyone? Yes, you are right. 1 byte horrible penmanship equals to 8 bit. 1 byte equals to 8 bit. Fine. What is a bit? You know, binary. 1, it's a bit. 0, again a bit. 1 1, it's 2 bits. So if I write 1 1 0 0 0 1 1 1, this is total 8 bits, and that will be equals to 1 byte. Clear? Now my connection is 1.5 Mbps. That means 1.5 megabits per second, not bytes per second. So suppose if your connection is 8 Mbps, 8 Mbps, 8 Mbps, right? Then your connection will be 8 megabit per second or 1 megabyte per second. Clear? 8 megabit per second or 1 megabytes per second, because the conversion rate is 1 byte equals to 8 bit. 1 into 8 x bit into 8 equals to x equals to byte. Bit into 8 equals to byte. Suppose you have 5 bit, that means you have 4. Suppose you have suppose you have, wait a second, yes, suppose you have 16 bits, then you will have 2 byte. Sorry, this is division. Yes, this whole is division. You get the overall idea, right? 16 bit equals to 2 byte, and 2 into 1024 byte equals to 1 megabyte. So where were we? Okay, you get the overall idea. So suppose 3 into 1024 megabyte equals to 3 gigabyte, right? So that's all about speed. Now network topologies, I'll wrap it up very soon. Topologies is a way in which we connect different computers. It's very old topology, bus topology, in which there's a thick cable. It is like a backbone, and all the other computers, all computers are connected to it by thin cable. Get it? This is thin cable, this is thick cable. Like suppose you are using some TV cable, right? There is your service provider will get you a connection from a wall jack in your wall. There's a wall, there will be a jack in it. You plug your TV cable and you get the connection. What happens? This is a single cable runs through whole your block and it provides connection to everyone. What's the problem of this topology? Suppose somehow this cable is damaged at this point. What will happen? Only this, and the service is coming from this way, so only this guy will get the service and these two will be doomed, right? So this is a very old topology anyway. Then comes ring topology. Have you heard of token rings? there's a token, it passes around all the computers in the ring, and it passes that data to all the computers. Right. This was ring topology. Nothing more to tell about this. Okay, most awesome topology, the star of all the topologies. Yes, it's star. I mean it's star topology. This is called star topology. In this topology, in this method, there is a switch in between and different computers are connected to it, right? So suppose even this link is broken, then service to these computers will be uninterrupted. They can share data among them. They can share data from internet. Get it? Only this guy will be left out. So basically, what topologies we using these days? Is it bus? Is it ring? Or is star? Let's see. Uh, Consider this figure. These are switches. Wait. These are switches. Okay. And different computers are connected. Some of you might say, dude, this is a bus topology because there is a backbone running in here and all the devices are connected to it. Some of you might say, no, this is a star topology because there is a switch in center and the computers and the devices are connected to it, right? If you take or all of these as a single node, then it will be a star. But this is neither. This is a combination of both. It is a combination of both the ring and both the bus and the star. This is a hybrid of both the topologies. Okay, this is what we use nowadays. Basically, this is what we use with some addition. We use this. So, how was it? How was today's class? I was exhausted, so sorry if I disappointed you. Anyway, there are a lot of career options in computer networks. You can go anywhere you want. You want to go to hardware networks, you will have a good earning there. You want to go to software networking school, go for anything. Fiber optics, you can work only with fiber optics. You can work only with routers and switches and routing tables. Computer networks is very cool. First, it might seem like building roads to different stations, to different machines, building roads, but it's much more than that. Trust me, it's way cool. Anyway, I want to wrap this up as quickly as possible. It's past 4. So thank you for watching. Thanks once again. Bye bye.